what do these three equations have in common? As you can see, of course, from the title, all of these three equations are technically quadratic equations, like by definition. Now, the definition of a quadratic equation is that it has to be an equation that has an x to the power of 2, when simplified, of course, and that it has to have only one variable. And it's usually shown in this format, in ax squared plus bx plus c, but it can be shown in other formats, and if it can be simplified down into this format, it is definitely a quadratic equation. As you can see with all of these three at the top, you can turn this into x squared plus 5x plus 6, which is basically the standard form with a equals 1, b equals 5, and c equals 6. The 2x squared minus 3x equals 5, you can move the 5 from the right to the left, basically minus 5 from both sides. So you can get 2x squared minus 3x minus 5 equals 0, in which case a is 2, b is negative 3, and c is negative 5. And lastly, we have negative 5x squared equals negative 5, which if you plus 5 on both sides, you get negative 5x squared plus 5 equals 0, which will turn into, a equals negative 5, b equals 0, and c equals 5. Now, of course, this has some limitations, and as you can see, a cannot be 0. If a is 0, then, well, it's just, there's not going to be any terms that have x squared in them. There's not going to have any terms which have the variable to a power of 2, which means that it's not going to be a quadratic equation anymore. Now, this definition is quite important, since most of the stuff that I'm going to be going over after this video is going to have to come back to this definition of what a quadratic equation is, since most of these require the equation to be a quadratic equation to actually be valid. Otherwise, it's just not valid. And yeah, here are some examples for the prerequisites of a quadratic equation. These four, I'll give you a little bit of time to think about which of these are actually quadratic equations. And if you need more time, you can always feel free to pause the video. Figured it out yet? Now, the answer is that the first two are indeed quadratic equations, but the last two are not. Now, the first two, as you can see, for the first one, you can move the 1, you can make minus 1 on both sides to get m squared plus n plus 1, which is pretty generic. It's basically the same as the standard form, this basic standard form. The x squared equals 0, though, however, you don't see specifically a term with the variable to the first power, and also you don't see a constant. However, these two terms still can exist with b equals 0 and c equals 0. Therefore, you just need the x squared, and you just need at least one constant to be able to make a quadratic equation. Now, 3 is not a quadratic equation due to it having two variables, both x and y. That immediately disqualifies it from being a quadratic equation. And lastly, x squared minus 3 equals x minus 1 times x minus 4. That's, when simplified, turns into 5x minus 7 equals 0, which does not have a term which has x squared. Which means that, well, it's not a quadratic equation because it doesn't have a term that has x to the power of 2. And here I leave you with a few more questions for you to try out for yourself.